Today's video we are going to prove the formula for the skewness of a log-normal random variable. So let's start. Let's begin with define the random variable y tilde distributed log-normally with parameter mu and sigma square. Then the skewness, denoted here by gamma, is simply the ratio between the third simple moments of the given random variable divided by the standard deviation power 3 of the same random variable. This is the formula for the skewness of the log-normal distribution, and we can see that it does not depend on the parameter mu. Therefore, what we are going to do in the next slide is to choose a suitable value for the parameter mu in order to prove more easily this result. And therefore we will choose the simplest values possible, therefore mu equal to 0. Then here we recall what is the third central moment, which is the expected value of the difference between the realization of the random variable y and the expected value of the random variable itself, power 3. Then here we are going to simply apply the polynomials rule, and then therefore at this stage we can see by doing a little bit of algebra that this is the final result. Then at this point we are going to recall that this result has been shown in previous videos. You can find it in log-normal moments of log-normal distribution, and where therefore I simply recall it. So the jth moments of a random variable log-normally distributed is simply the exponential power j multiplied by mu plus j square multiplied by sigma square divided by 2. Strong of this result, therefore we put mu equal to 0 and we simplify it to epsilon power j square multiplied by sigma square divided by 2, and therefore here we're going to simply apply what I've shown on the top of on the slide, and put this result in the formula of the third central moments, the third simple moments. Therefore, the first term, it is the expected value of y tilde power 3. Then the second item is 3 times the expected value of y tilde power 2 multiplied by the expected value of y. And then the second, the last and the third component is 2 times the expected value of y tilde power 3. Then we collect the common term in all the terms, which is epsilon power 3.5 multiplied by sigma square, and then we have this polynomial in the in the circle brackets, and then by doing simple algebra we can decompose this polynomial in the product of these two polynomials, which are useful for the simplification which that will be needed in the future, in the next step, which is the division by the standard deviation power 3. Therefore we recall here which is the standard deviation of a log-normal random variable, which is therefore the product between exponential power sigma square divided by 2 multiplied by this term in under the square roots, which represent the coefficient of volatility, which it is explained in the video that I recommended before. Then we just take to the power 3 this term, and then we can see that we can simplify something, especially the first term. They are both simplified, and also the term elevated to the power of 3.5, and therefore this is the final result. And from this result we can see that also the skewness depends on the coefficient of volatility of the random variable, and this is reasonable because if the coefficient of volatility of the random of log-normal distribution increases, it means that there is the possibility to encounter more extreme values on the right hand side of the random variable, since the our log-normal distribution is includes only the positive terms of the real line. Thanks for watching, and see you in the next videos.